Hello friends, today we'll discuss more about basic electrical engineering. In the last class we have discussed about resistance, inductance, capacitance, and now today we'll discuss how they are connected in a electrical network. So before going to discuss about basics of Kirchhoff's laws, we will first discuss what is network and circuit. What is the network and what is circuit? There is a simple difference between network and circuit. If the network is closed, then it is called circuit. If the network is closed, then it is called circuit. If it is not closed, if it is not closed, then it may be network. It may be network, but it cannot be called as a circuit. Called as a circuit. So in interview some committee will tell you that differentiate between network and circuit. The simple answer is a circuit is always closed and a network may be closed, may not be closed. Next we will discuss in a circuit or network some terms comes, those are we will discuss today. That is node. We will discuss those are node. What are node? What are junction? What are branches? In a electrical circuit, what are branches? Then what is active element? Active element. And what is passive element? Passive element. Next, what do you mean by loop and what do you mean by mesh? These are the common things you should know in basic electrical concept. So node means where the two or more currents meet. Branch currents meet at a point. Junction, more than two, there may be 3 or 4 currents meeting at a point. Branches, between two nodes we are having a branch. Active element means that may be having energy source. Active element means the elements has energy source. For an example, voltage has energy source, current source has energy source, so they may be called as active element that amplify the circuit. Transistor may be called as a active element, but that comes under electronics. Again, passive elements. Passive elements only stores energy. Passive elements only stores energy. And the RLC that we have discussed earlier are called as passive elements. Loop means you are having a loop inside a big loop, but mesh is individual. That means unique. You cannot have a mesh inside a mesh. So we will have one example regarding this so that your concept will be more clear. For an example, I will draw a electrical circuit. So having resistances, inductances and capacitances like this. So this is your resistances 1, resistance 2, this is your inductance, this is your capacitance, this is suppose EMF E. It is, so we have to see here how many nodes are there, how many branches are there, how many loops are there, how many meshes are there. So here, if you will look at, this may be called as a node, this may be called as a node, this may be called as a node, this may be called as a, suppose here you are having also two resistances, or you may having another inductance. Suppose this is L1, this is L2, suppose this is your R1, R2, R3. So 3, 4, 5, 6. You are having 6 nodes, whereas you are having branches 1, 2, 3, 4, 5, 6, 7 branches. And how many loops? 7 branches, 6 nodes, and you are having 6 nodes, loops. You are having, this is loop 1, this is your loop 2, and this is your loop 3. You are having 3 loops, and you are having 2 mesh. Mesh 1, this is your mesh 2. 2 mesh. This is one example of differentiating nodes, branches, loops, mesh, and this may be a junction 1, 2, 3. This may be a junction. This may be a junction 1. This is junction 2. However, I will draw another circuit in which, for an example, if I will draw another circuit like this is a resistance, this is a capacitance, this is an inductance. In this case, we are having 1, 2, 3, 4, 4 branches, but nodes is only 2 nodes. 1, 2, 2 nodes. Why we are having, what is the difference between these two circuits? In previous circuit, between these 2 points we are having an element, we are having one element, but here this is like a short circuit. So these points will be treated as 1 point, and this will be treated as another 1 point. So that's why you are having 2 nodes, 4 branches, and 1 loop, 2 loop, 3 loop, 4 loop, 5 loop, and 6 loops. 6 loops, and you are having 1, 2, 3, 3 meshes. So these are the common things in electrical engineering. With this concept, we will now switch over to the first article, that is Kirchhoff's laws. First law. So we will go to first article, that is Kirchhoff's laws. So Kirchhoff has 2 laws, and one law is known as KCL, that is Kirchhoff's current law, and another one is Kirchhoff's voltage law. Kirchhoff's voltage law. So first we will discuss Kirchhoff's current law. So Kirchhoff's current law states that all the currents meeting at a junction is equals to 0. Kirchhoff's current law, commonly known as KCL, it states that all the currents meeting at a junction is equal to 0, or we can say all the incoming currents, all the incoming currents is equals to all the outgoing currents. This is a very simple law. Its application is everywhere. That means in all the electrical as well as electronic circuits. I am giving a small example to solve this KCL. For an example, I will have a Wheaton's bridge. Suppose this is your Wheaton's bridge, and in this Wheaton's bridge we are having currents in different branches. We are having currents in different branches. Suppose this is your I1, this is I2, this is I3, this is I4, this is I5, this is I6, and this is I7. This is suppose EMF. Suppose in the question given I1 is equals to 12 ampere, I2 is equals to 5 ampere, and I5 is equals to 4 ampere, and it is telling that find the currents in the rest branches in the circuit. In the circuit rest branches, we have to find out the currents. If you look at this figure, you can see that the I1 current is same as I7 current. So total current is same, I7 current. So we can say that I1 is equals to I7 is equals to 12 ampere. Now suppose this is your node 1. So if we will apply KCL to node 1, applying KCL to node 1. If node 1 will apply KCL, then what will happen? I1 is the incoming current, outgoing current is I2 and I3, I2 plus I3. So I1 is 12, I2 is 5 plus I3. So I3 will be 7 ampere. So we got the value of I3. Similarly, we can find out here I4. If we will apply here KCL, this I2 current is 5 and this I4 and I5 are outgoing. This is 5, I4 is 4, so I4 definitely will be 1 ampere. So 1 ampere, this is your I6. These two are the, if we will apply here KCL, then what will happen? This is your incoming current, I5 is the incoming current, I6 is the incoming current, and I7 is the outgoing current. So I5 is 5 ampere and I7 is 12. So I6 definitely will be definitely, this is 5, this is I6. So I6 will be definitely 7 ampere. I6 will be 7 ampere. So this is a KCL is very simple to solve KCL related problems. So we will discuss in the next class about KVL and related problem. Thank you. Hmm? Hmm? Oh, hmm. And my dear students, if you like this video, please share, comment, and like my subscribe my channel and press the bell icon. Thank you very much.